so what have we done so far? We have multiplied and we have simplified rational expressions, and then we've also multiplied and divided. So the next logical step would be to add them and subtract them. Now usually you do adding and subtracting first, because usually adding and subtracting is easier than multiplication and division. But what are we dealing with in this particular section? What kind of numbers are we dealing with? Fractions. And when it comes to fractions, multiplication and division is actually easier than addition and subtraction. Why is that? Exactly. I like to think. That's right. When you multiply and divide fractions, you don't need to find common denominators, whereas with addition and subtraction, you do. Now, we're used to doing addition and subtraction, where all you got to do is multiply one number together, and that gets you your least common denominator. With these rational expressions, it's going to be more complicated than that. So rather than just jump right into addition and subtraction, what we're going to first do is find the least common multiples of two expressions. And once you're comfortable with finding the least common multiples, then we can go into adding and subtracting. Because if you don't have a good grasp of this part, the adding and subtracting is going to be extremely confusing. Even more confused than you usually are. Which granted is difficult, but for some of you, I'm not sure it's possible. I think some of you are at the limit of confusion on a daily basis in here. Alright, so here's my two expressions, and I'll give you a second or two to write them down. Okay, is anybody not done? Who? Madonna back there? I prefer Madonna. Joey? You guys having gender identity? Not that there's anything wrong with it. You ready, Joey? Joey? Okay, so the first thing we're going to do is we're going to factor the trinomial. That's the first step, is to factor the trinomial. So even though this is one problem, we're treating these expressions separately until the end. So at first we're going to treat these separately. We're not going to do anything to them together. So I guess I should have erased this, but we can do it together. But something to remember for 7 minutes. So we want the factors of 1 that add up to 2. Duh. 1 plus 1. And then the factors of 4 that add up to 5. Almost as easy. Factors of 4 that add up to 5, of course, are 4 and 1. I'm in a hurry. So again, let me reiterate that if factoring is still not a strength for you, please take some time and look at that website we had discussed. Practice your factoring. You'll see how useful and how necessary it is for this section of the text. Alright, so once you factor the trinomials, once we factor, okay, so the next step is to deal with the numbers, the 12 and the 18. And for that we're going to do a prime factorization. So if that doesn't come readily to you, all you have to do is make factor trees. So my two numbers were 12 Okay, factors of 18, please. 9 and 2. Again, 2 is the prime number. Factors of 3. 3 and 3. See how easy that was? Yes, please. Okay, so we get our prime factors, and then we're going to rewrite just the number parts. So my 12 was 2 squared times 3, and then everything else down. The x plus 1, we can change a little bit. Instead of writing x plus 1 times x plus 1, we can write x plus 1 squared. The 18 was 3 squared times 2, and then everything else just gets rewritten. Okay, so far nothing earth-shattering in terms of difficulty. Factoring, which we've done, both for the trinomials and for the regular numbers. So hopefully no one is confused yet. Simone, you're confused? I hope so. Go ahead, you're confused. Lady in the back ready? Joey? Okay, so the next step. No, you're not ready? Now you're ready. Okay, the next step is that identify the greatest power of each factor that occurs in each expression. And what that means is, what you want to do is you want to line up all the factors of each number that we came up with. So for example, for the top one, we had this. We had 2 squared times 3 times x squared times y times x plus 1 squared. And then what you want to do is you want to take the other one and underneath it, underneath the number. So for example, how many 2's we had? We had 2, and then we had 3 squared, and then we had x, and then we had y to the third, and then we had x plus 1, and then we had x plus 4. So you can see what you're doing is you want columns for a reason. The reason you want columns like that is because you want to find the greatest power of each factor. In other words, I have 2 squared here and I have 2 here. I have 2 squared as my greatest factor. So I'm going to circle or underline or highlight. I'm going to somehow differentiate the bigger one. So you do that for each factor in your list. So for the 3's, it's 3 squared. For the x's, it's x squared. For the y's, it's y to the third. For the factor x plus 1, and this is why we wrote it as x plus 1 squared. And then finally, x plus 4. There is no factor x plus 4 on the top, so it's our greatest factor. Okay, so that is step number 2. Go ahead.
Why did you circle the circle?
Because it's the greatest power, the highest exponent of each factor. So I have 2 here versus 1 here. So I circled the 2. I have 1 3 here and 2 3's here.
For the bottom one, wouldn't the 3 be first and the 2?
What do you mean multiplication, where it doesn't matter, remember?
Where you're doing it from top to bottom.
You're comparing like terms. You want to be able to look at them easily. You want to be able to compare them easily. Do you have to write it like this? No. You can write it any way you like. As long as you list all the terms in a row. But it's easier, I think, to have to choose right in a row and then pick the number and pick the exponent that's higher. Right? I think so. Try it a different way and see if you like that better. I don't have a monopoly or patent on how to do this problem. If you find a different way that you like better, by all means, use it. Yes. Yes. We did that. Remember we did this? The tree. Okay. So the next step is to write the product of the identified factors. That's what this says. Write the product of the identified factors. In other words, you're going to take all the ones that you've circled or highlighted or underlined, all the ones that you picked, and you're going to write them in a row. So I have 2 squared times 3 squared times x squared times y to the third times x plus 1 squared. Try that again. Times x plus 1 squared times x plus 4. Okay, but you really keep in the back of your mind what we're building towards. What we're building towards is we're going to have 2 fractions that we're going to be adding. But in order to add the fractions together, the denominators are going to have to be the same. So that's what you're doing here. You're creating that least common denominator. You'll see tomorrow when we do adding and subtracting what I'm talking about. But because this is more complicated than simply, okay, if I have 1/2 plus 1/3, what's the least common denominator? 6. It's much easier. Here we've got all kinds of stuff going on, and we need a more systematic way to find that least common denominator. Okay, so the last step is to simplify. In other words, and that really relates to numbers only. You're now going to multiply those numbers together. So you're going to do 2 squared, which is 4, times 3 squared, which is 9. 4 times 9 gives me 36. And then you're going to squish everything else together. X squared, y to the third, x plus 1 squared, x plus 4. That's going to become, if I had these 2 things as fractions, this would be the least common denominator of those 2 fractions. Yes?
What are these for?
Because it's a factor, and it's the only factor of x plus 4, so it's got to be part of it. It's got to be part of your least common multiple. Yes. Okay, does anybody have any questions? Okay, I think we have time for you to do one. So, you do this one. So what can I, guys, you gotta remember, when it's a trinomial, you're gonna have 2 sets of parentheses.
Right.
When it's a binomial,
One set.
unless it's a perfect square, you're gonna have one pair of parentheses, not one pair, just one pair of parentheses. When you have something, when you have a binomial that you're factoring, that's when you're gonna divide stuff out of your binomials. What can I divide 2 and 4 by? 2. So this gives me 2, and what's left over once I divide 2 out? X plus 2. Okay, this one over here, I need this one I'm going to get 2 pairs in parentheses, because it's a trinomial. So I need the factors of -6 that add up to -1. X minus 3, x plus 2. Now I think this one is actually simple enough that you don't have to necessarily line stuff up. In fact, there's no squares, there's no real comparison here. There's only one factor that they even have in common, and that's the x plus 2. But since there's only one of them, it doesn't matter which one we choose from. We're just going to make sure we pick the x plus 2. So we take the 2 from here, we take one of the x plus 2's. Does it matter which one? No. Who's going to ever know? Just x plus 2. And then we have an x minus 3 over here that gets added. And that is my answer. What? What do you think?